is I'm going to want to make sure that I eliminate as many things underneath a square root as possible, because once I have the square root of a binomial or something, that gets very hard to integrate. So probably the best thing that I could choose to use as my u is 4 minus root x. So that means du, uh, derivative of 4 is 0, is negative 1/2 x to the negative 1/2 times dx, which if I solve for dx, I get negative 2 root x du. So that's kind of going on over there. So if I take a look at this, I'm going to treat this like it's an indefinite integral for a little bit, or I might change the bounds later. But I have indefinite integral of the square root of u times negative 2 root x du. So obviously I still have a u and I have an x, and so I can't integrate this at the moment. But one thing I can do is, since I have a root x in here, I can kind of figure out what's actually going on. So if I take a look at what I originally had as u, it was equal to 4 minus root x. So if I rearrange terms, root x is the same thing as 4 minus u. So I can uh, replace this root x with 4 minus u. So I have the integral of root u, and I'm going to, since everything's multiplied together, I'll move that negative 2 to the outside. That'll make it easier. Root u times negative 2 moved to the outside, and then root x is the same thing as 4 minus u. So now I can actually integrate this. I'll now split this into two different ways. So if I treat this like it's an indefinite integral, um, I'm going to uh, write negative 2 times the integral of, remember, root u is the same thing as u to the 1/2. So 4 u to the 1/2 minus u to the 3/2 du. So I'm going to integrate these. So I have negative 2 times 4 times 2/3. So that becomes 8/3 u to the 3/2 minus 2/5 u to the 5/2. And then I'm going to sub in what I originally had as u, and that was 4 minus root x. So let's continue. Negative 2 times 8/3 4 minus root x to the 3/2 minus 2/5 4 minus root x. This line is kind of getting in the way. To the 5/2. And then I evaluate this from 0 to 9. So if I evaluate this from 0 to 9, I'm going to take 9 and sub it in everywhere there's an x. So I have negative 2 times 8/3. And then if I sub in 9, I get 4 minus 3, which is 1 to the 3/2, minus 2/5, 4 minus 3, which is 1 again. And now I have to subtract what happens when I sub in 0. So in this case, when I sub in 0, I get 8/3 times 4 to the 3/2, which is 8, plus, because I have minus a negative, 2/5, and then 4 to the 5/2 is 32. So I end up with negative 2 times 8/3 minus 2/5 minus 64/3 plus 64/5. And that could be simplified at your leisure. The main thing that I want to do is show you that it's also the same to do it the other way. So how do we change the bounds in a problem like this? We can change the bounds in a problem like this because I have to take 0 and 9 in where x is. So u, if I sub in 0 and 9 for x, u becomes 4 and u becomes 1. So this becomes -2 times the integral from 4 to 1 of whatever was up here. So it's u 4u to the 1/2 minus u to the 3/2 du. Now notice that the 4 and the 1 are not in spots that we tend to like them to be in, but also notice what happens when we get all the way to the end. Notice that we're subbing 1 in first and we're subbing 4 in second. It's 4 to the 3/2 and 4 to the 5/2 are 8 and 32 respectively. So it actually ends up being backwards. So you could do this this way, or you could say it's 2 times the integral from 1 to 4 of 4u to the 1/2 minus u to the 3/2 du. And you end up getting exactly the same thing that you got originally when you're all done.